A cirque is a theater-like valley formed by glacial erosion. Alternative names for this landform are corrie and cum. A cirque may also be a similarly shaped landform arising from fluvial erosion. The concave theater shape is open on the downhill side corresponding to the flatter area of the stage, while the cupped seating section is generally steep, cliff-like slopes down which ice and glaciated debris combine and converge from the three or more higher sides. The floor of the cirque ends up bowl-shaped as it is the complex convergence zone of combining ice flows from multiple directions and their accompanying rock burdens. Hence it experiences somewhat greater erosion forces, and is most often overdeepened below the level of the cirque's low-side outlet and its downslope valley. If the cirque is subject to seasonal melting, the floor of the cirque most often forms a tarn behind a moraine, glacial till a bedrock lip marking the downstream limit of glacial overdeepening of the basin, which serves as a dam at the outlet. Another form of cirque found in karst landscapes, is formed by intermittent river flow cutting through layers of limestone and chalk leaving sheer cliffs. A common feature for all fluvial erosion cirques is a terrain which includes erosion-resistant upper structures overlying materials which are more easily eroded. Formation: glacial erosion cirque formation. Glacial cirques are found amongst mountain ranges throughout the world. Classic cirques are typically about 1 kilometer long and 1 kilometer wide. Situated high on a mountainside near the fern line, they are typically partially surrounded on three sides by steep cliffs. The highest cliff often is called a head wall. The fourth side forms the lip, threshold or sill, the side at which the glacier flowed away from the cirque. Many glacial cirques contain tarns dammed by either till or a bedrock threshold. When enough snow accumulates, it can flow out the opening of the bowl and form valley glaciers which may be several kilometers long. Cirques form in conditions which are favorable. In the northern hemisphere, the conditions include the northeast slope where they are protected from the majority of the sun's energy and from the prevailing winds. These areas are sheltered from heat, encouraging the accumulation of snow. If the accumulation of snow increases, the snow turns into glacial ice. The process of nivation follows, whereby a hollow in a slope may be enlarged by ice segregation, weathering, and glacial erosion. Ice segregation erodes the vertical rock face and causes it to disintegrate, which may result in an avalanche bringing down more snow and rock to add to the growing glacier. Eventually, this hollow may become large enough that glacial erosion intensifies. The enlarging of this open-ended concavity creates a larger leeward deposition zone, furthering the process of glaciation. Debris in the ice also may abrade the bed surface. Should ice move down a slope, it would have a sandpaper effect on the bedrock beneath, on which it scrapes. Eventually, the hollow may become a large bowl shape in the side of the mountain, with the head wall being weathered by ice segregation, and as well as being eroded by plucking. The basin will become deeper as it continues to be eroded by ice segregation and abrasion. Should ice segregation, plucking, and abrasion continue, the dimensions of the cirque will increase, but the proportion of the landform would remain roughly the same. A bergschrund forms when the movement of the glacier separates the moving ice from the stationary ice, forming a crevasse. The method of erosion of the head wall lying between the surface of the glacier and the cirque's floor has been attributed to freeze-thaw mechanisms. The temperature within the bergschrund changes very little, however. Studies have shown that ice segregation may happen with only small changes in temperature. Water that flows into the bergschrund can be cooled to freezing temperatures by the surrounding ice, allowing freeze-thaw mechanisms to occur. If two adjacent cirques erode toward one another anorete, or steep-sided ridge, forms. When three or more cirques erode toward one another, a pyramidal peak is created. In some cases, this peak will be made accessible by one or more aretes. The Matterhorn in the European Alps is an example of such a peak, where cirques form one behind the other. A cirque's airway results as at the Zassler Loch in the Black Forest. These glaciers can only originate above the snowline. Studying the location of present-day cirques provides information on past glaciation patterns and on climate change. Fluvial erosion cirque formation. Both, although a less common usage, the term cirque is also used for theater-shaped, fluvial erosion features. For example, an approximately 200 square kilometers anticlinal erosion cirque is at 30.583 degrees north, 34.750 degrees east, 30.583, 34.750 on the southern boundary of the Negev Highlands. This erosional cirque Maktesh was formed by intermittent river flow in the Maktesh Ram uncutting through layers of limestone and chalk, resulting in cirque walls with a sheer 200 meters drop. The Cirque du Bas-du-Monde is another such a feature, created in karst terrain in the Burgundy region of the department of Côte d'Or in France. Yet another type of fluvial erosion-formed cirque is found on Union Island, which includes the tallest volcanic structure in the Indian Ocean. The island consists of an active shield volcano and an extinct, deeply eroded volcano. Three cirques have eroded there in a sequence of agglomerated, fragmented rock and volcanic breccia associated with pillow lavas overlain by more coherent, solid lavas. A common feature for all fluvial erosion cirques is a terrain which includes erosion-resistant upper structures overlying materials which are more easily eroded. Notable cirques: Australia Blue Leg Cirque, New South Wales, Australia; Asia Chandra Tal, Himachal Pradesh, India; Cirque Valley, Hindu Kush, Pakistan; Western Khumbu Himal, Nepal; Europe; Cirque de Gredos, Sierra de Gredos, Spain; Cirque de Gavarnie, Pyrenees, France; Cirque d'Astobe, Pyrenees, France; Cirque de Traumas, Pyrenees, France; Cirque du Feu-Cheval, Savoy Alps, France; Corrie and Tiesnichte, Grampian Mountains in the Scottish Highlands near Znakotli, Karkonosz, Poland; Kumshingborn Leg, County Waterford, Ireland; Europe; Cirque de Navachels, Grande Courses, France; Cirque du Bas-du-Monde, Grande Courses, France; Cirque du Bas-du-Monde, Burgundy, France. North America: Cirque of the Towers, Wyoming, United States; Iceberg Cirque, Montana, United States; Summit Leg Cirque, and others on Mount Evans, Colorado, United States; Great Basin and others on Mount Katahdin, Maine, United States; Great Gulf, New Hampshire, United States; Tuckerman Ravine, New Hampshire, United States;